Swayam Prabha. Digital India. Educated India.
Now we are going to discuss the permutation and combination. Let us start with one example so that you can understand the meaning of permutation. In how many ways we can select 3 students from a group of 5 students to stand in line for a picture? In how many ways can we arrange all 5 of these students in a line for a picture? So, this is a question. Based on this question, we have to define the meaning of the selection and combination arrangement. Now, the solution to this question is, first note that the order in which we select the student matters. There are 5 ways to select the first student to stand at the start of the line. Once this student has been selected, there are 4 ways to select the second student in a line. After the first and second students have been selected, there are 3 ways to select the third student in the line. By the product rule, we know 5 into 4 into 3 equal to 60 ways to select the student from a group of 5 students to stand in a line for a picture. To arrange all 5 students in a line for a picture, we select the first student in 5 ways and second student in 4 ways, third student in 3 ways and fourth in 2 ways and fifth in 1 ways. So that there are the possibilities of selection is 5 into 4 into 3 into 2 into 1 equal to 120 ways to arrange all 5 students in line for a picture. So, this way we can do for the arrangement of a group of 5 students. So, this way we can start with a permutation. So, permutation means the set of distinct objects is an ordered arrangement of these objects, and we are also interested in order of arrangement of some of the elements of the set, and order of the arrangement of all elements of a set is called OR permutation, right. For example, let S equal to 3 numbers 1, 2, 3. The order arrangement is 3, 1, 2 is a permutation of S. The order arrangement is 3, 2 is a 2 permutation of S. So, this is the meaning of ordered arrangement of the permutation. The number of OR permutation of a set with n elements is denoted by P of n comma R or NPR. So, we can find the P of n comma R using the product rule. For example, you take a set A, B, C. The 2 permutation of S are the ordered arrangement A, B, A, C, B, A, B, C, C, A, and C, B, only these possibilities we can do for the 3 numbers. Consequently, there are 6 2 permutation of this set with 3 elements, and there are always 6 2 permutation of the set with 3 elements, and there are 3 ways to choose the first element of the arrangement, and there are 2 ways to choose the second element of the arrangement, because it must be different from the first element. Hence, the product rule says that 3p2 is nothing but 3 into 2, which is equal to 6. This is the first element, but the product rule follows that 3p2 is nothing but 3 into 2 equal to 6. So, this way we can do for product rule. Now, we use the product rule to find a NPR where N and R are positive integers with 1 less than or equal to r less than or equal to n. Now, we have a theorem. If n is a positive integer, r is an integer with 1 less than or equal to r less than or equal to n, then there are NPR equal to n into n minus 1 into n minus 2 into and so on n minus r plus 1, which is a R permutation of a set with n distinct elements. So, this is the meaning of general form of NPR. Now, we have a proof. We will use the product rule to prove that this formula is correct. The first element of the permutation can be chosen in n ways, because there are n elements in the set, and there are n minus 1 ways to choose the second element of the permutation, because there are n minus 1 elements left in the set. After using the element picked for the first position, similarly there are n minus 2 ways to choose the third element and so on, until there are exactly n minus of r minus 1 equal to n minus r plus 1 ways to choose the rth element, and consequently the product rule says that n into n minus 1 into n minus 2 and so on n minus r plus 1 with R permutation of the set. So, this way we can prove the general form of NPR. And also we note that NP0 is 1, where n is a non-negative integer, because there is exactly one way to order 0 elements, that is, there is exactly one list with no elements in it, namely empty list. By corollary says that if n and r are integers and r lies between 0 to n, then NPR equal to n factorial by n minus r factorial. So, this is the formula for finding permutation with n elements with respect to the r. Now, we have a proof. When n and r are integers and 1 less than or equal to r less than or equal to n, by theorem one says that the product rule of P of n comma r is nothing but n into n minus 1 into n minus 2 and so on n minus r plus 1 equal to n factorial by n minus r factorial, because n factorial by n minus 0 factorial is equal to n factorial by n factorial, which is equal to 1. So, wherever n is a non-negative integer, then the formula says that NPR equal to n factorial by n minus r factorial. Also, it holds for when r equal to 0. Now, we have some example of permutation. How many ways are there to select the first prize winner, second prize winner, third prize winner from 100 different people who have entered a contest? So, the answer is, now it is a matter which person wins which prize. So, number of ways to pick the 3 prize winner is the number of order selection of 3 elements from a set of 100 elements. That is, the number of 3 permutation of a set of 100 elements. Therefore, consequently, the answer is 100p3 is nothing but what? 100 into 99 into 98, which is equal to 9,70,200, 9,70,200. So, this way we can do for selecting winners from 100 different people. And next example, suppose that there are 8 runners in a race. The winner receives a gold medal, the second place finisher receives the silver medal, the third place finisher receives a bronze medal. How many ways, the different ways are there to award these medals, if all possible outcomes of the race can occur and there are no ties? So, the The answer is the number of different ways to award the medal is the number of 3 permutation of a set with 8 elements. Hence, there are 8p3 medals can be chosen, that is 8p3 is nothing but 8 into 7 into 6, which is equal to 336 people ways to award the medals. So, this is the way we can choose the outcome of the race can be occurred, and the conditionally there are no ties. Another example is, suppose that a saleswoman has to visit 8 different cities. She must begin her trip in a specified city, but she can visit the other 7 cities in any other she wishes. How many possible orders can saleswoman use when visiting these cities? So, this is the question. Now, the answer is the number of possible paths between the cities in the number of permutation of the 7 elements, because the first city is determined, but the remaining 7 can be ordered arbitrarily. Consequently, there are 7 factorial, which is equal to 7 into 6 into 5 into 4 into 3 into 2, which is multiply them, the resultant is 50-40 ways for the saleswoman to choose her tour. If, for instance, the saleswoman wishes to find the path between the cities with the minimum distance, and she computes the total distance for each possible path, she must consider the total of 5040 paths. So, this is the answer to the question. Next example, how many permutation of the letters A, B, C, D, E, F, G, H containing the string ABC? Now, we have 8 letters containing the string ABC. We have what? ABC must occur as a block, and using this block, and we have finding the permutation of 6 objects, namely the block A, B, C, and the individual letters D, E, F, G and H. Therefore, the 6 objects can occur in any order, and there are what 6 factorial ways of the permutation occurred in the letter of A, B, C, D, E, F, G, H, that is 6 factorial equal to 720 permutation of the letters A to H of 8 letters, in which ABC occurs as a block. So, this way we can do the problem. I hope you can understand the step. Next, we will go to discuss combination. Now, how many different committees of 3 students can be formed from a group of 4 students? To answer this question, we need only find the number of subsets with the 3 elements from the set containing the 4 students. We see that there are 4 such subjects, 1 for each of the 4 students, because choosing the 3 students is the same as choosing one of the 4 students to leave out of the group. This means that there are 4 ways to choose the 3 students from the committee, where the order in which these students are chosen does not matter. So, that is the meaning of this problem. Now, this example illustrates that many counting problem can be solved by finding the number of subsets of a particular size of a set with n elements, where n is a positive integer, and OR combination of the elements of a set is an unordered selection of OR elements from the set. Thus, an OR combination is simply a subset of the set with the OR element. So, this is the note we have to know, that if the committee of 3 students or n students can be formed from n plus 1 students, like that, this methodology we have to apply. Then one more example, let S be a set 1, 2, 3, 4, then 1, 3, 4 is a 3 combination from S. Note that 4, 1, 3 is same as 3 combination as 1, 3, 4, because the order in which element of set are listed does not matter. So, this way also we can do that. Therefore, NCR is also denoted by C of n comma r and is called a binomial coefficient. Another example, we see 4C2 or C of 4 comma 2, meaning is what? 4C2, right, that is 4 into 3 by 1 into 2. So, if you cancel it, the resultant is 6. So, we can see that NCR or 4C2 is nothing but 6, because 2 combination of ABCD are 6 subsets, let it be A comma B, A comma C, A comma D, B comma C, B comma D and C comma D. So, directly we can write the according to combination definition this possibilities written in terms of the notation 4C2. We will discuss theorem 2, the number of R combination of a set with n elements, where n is a non-negative integer and R is an integer with 0 less than or equal to R less than or equal to n equals NCR equal to n factorial by R factorial into n minus R factorial. The proof is NPR mean R permutation of a set can be obtained by forming the NCR combination of the set. Then ordering the elements in each R combination can be done with RPR ways. Consequently, by product rule, NPR is equal to NCR into RPR. So, that this implies NCR equal to NPR by RPR, which is equal to n factorial by n minus R factorial, and then R factorial by R minus R factorial, which is equal to n factorial by what? R factorial into n minus R factorial. So, we can also use the division rule for counting the constructive proof of this theorem, because the order of elements in a combination does not matter and there are NPR ways to order R elements in R combination of n elements. Each of the NCR having R combination of a set with n elements correspond to exactly RPR or permutation. Hence, the division rule says that NCR equal to NPR by RPR. This implies NCR equal to n factorial by R factorial into n minus R factorial, which is equal to NCR equal to R factorial n factorial by R factorial into n minus R factorial, and then n factorial can be written as n into n minus 1 into and so on n minus R plus 1 by R factorial. Now, we will go to the example 11. How many poker hands of 5 cards can be dealt from a standard deck of 52 cards? Also, how many ways are there to select 47 cards from a standard deck of 52 cards? The solution is, because the order in which 5 cards are dealt from deck of 52 cards does not matter, there are 52 C5 is equal to 52 factorial by 5 factorial into 52 minus 5 factorial, 52 minus 5 factorial, which is equal to 47 factorial, different hands of 5 cards that can be dealt. So, to compute the value of 52C5, first divide the numerator and denominator by 47 factorial to obtain what 52C5 is equal to 52 into 51 into 50 into 49 into 48 and so on 1 factorial divided by 1 to 47 into 1 to 5. So, that 1 to 47 get cancelled, the remaining is 52 into 51 into 50 into 49 into 48 divided by 5 into 4 into 3 into 2 into 1. Now, this expression can be simplified by first dividing the factor 5 in the denominator into the factor 50 in the numerator to obtain a factor 10 in the numerator. Then dividing the factor 4 in the denominator into the factor 48 in the numerator to obtain the factor 12 in the numerator. Then dividing the factor 3 in the denominator into the factor 51 in the remaining to obtain a factor of 17 in the numerator, and finally dividing the factor 2 in the denominator into the factor 52 in the numerator to obtain a factor of 26 in the numerator. So, that the value of 52C5 is equal to 26 into 17 into 10 into 49 into 12, which is equal to 2,598,960 is a net value of this resultant. So, this way we can calculate the combination. Consequently, there are 2,598,960 different poker hands of 5 cards that can be dealt from a standard deck of 52 cards. So, there are 52C47 equal to 52 factorial by 47 factorial into 5 factorial, which is equal to what 47 cards from a standard deck of 52 cards. So, we do not need to compute the value because 52C47 is 52C5. Therefore, it follows that there are only 2,598,960 different ways to select 47 cards from a standard deck of 52 cards. So, this formula is for the quantities of order of the factor of 5 factorial and 47 factorial in the different denominator in the formulae for these quantities. Now, further based on this as some corollary, let n and r be a non-negative integer with r less than or equal to n. So, that NCR equal to NC n minus r. So, the proof is from the theorem it follows that NCR equal to n factorial by r factorial by n minus r factorial, and then NC n minus r is equal to n factorial by n minus r factorial into n minus of n minus r factorial, which is equal to n factorial by n minus r factorial into r factorial. Hence, NCR equal to NC n minus r. Another example, how many ways are there to select 5 players from a 10-member tennis team to make a trip to match at another school? So, the solution is by the number of 5 combination of a set with 10 elements. By theorem, the number of such a combination is 10C5 equal to 10 factorial by 5 factorial to 5 factorial, which is equal to 252, right. That is n factorial by n minus r factorial into r factorial is equal to 10 factorial by what 5 factorial into what 10 minus 5 factorial, which is equal to 10 factorial by 5 factorial into 5 factorial. So, this way we can do for what 5 players from a 10 members tennis team to make a trip to match the another school. On the next example, in a group of 30 people have been trained as astronauts to go on the first mission to Mars. How many ways are there to select a crew of 6 people to go on this mission, assuming that all the crew members have the same job. The solution is the number of ways to select a crew of 6 from the pool of 30 people is the number of 6 combination of a set with 30 elements, because the order in which these people are chosen does not matter. So, by theorem, the number of such a combination is 30 C6 equal to 30 factorial by 6 factorial into 24 factorial, which is equal to 30 into 29 into 28 into 27 into 26 into 25 into 1 so on 1 by 1 into 2 into 3 into and so on 24 into 6 into 5 into 4 into 3 into 2 into 1 and cancel up to 24 1 into 24. So, that the resultant is numerator is 30 into 20 30 up to 25 30 into 29 into 28 into 27 into 25 into 26 by what 6 into 5 into 4 into 3 into 2 into 1. So, the resultant is 593,775. So, 5,93,775. Next, how many bit strings of length n contain exactly R ones? So, the solution is the position of R ones in the bit string of length n form an R combination of a set of 1, 2, 3 and so on n. Hence, there are NCR bit strings of length n that contain exactly R ones. Therefore, this is the answer to the what? Length of R n containing exactly R ones. Suppose that there are 9 faculty members in the mathematics department and 11 in the computer science department. How many ways are there to select a committee to develop a discrete mathematics course at a school if the committee is to consist of 3 faculty members from the mathematics department and 4 from the computer science department? So, the answer is by product rule, the answer is the product of number of 3 combination of a set with 9 elements and the number of 4 combination of a set with 11 elements. By theorem, the number of ways to select the committee is 9C3 is into 11C4, which is equal to 9 factorial divided by 9 minus 3 factorial into 3 factorial, 11 factorial by 11 minus 4 factorial into 4 factorial. So, which is equal to 9 factorial by 3 factorial into 6 factorial, and for second one 11 factorial by 4 factorial into 7 factorial, which is equal to 84 into 330, which is equal to 27,720. So, this way we can choose the committee to develop a discrete mathematics course in the way if to consist of 3 faculty members from the mathematics department and 4 from the computer science department. So, there ends. Now, we will discuss the next topic.